This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas.
Imagine this. Horeana, India, summer of 2022. It's just unbearably hot.
And brutal is the word.
Yeah, brutal. There's this farmer, Preetam Singh, and he's watching temperatures climb past anything normal, hitting like 127 degrees Fahrenheit.
An absolutely staggering record.
And that heat, it wasn't just uncomfortable, it absolutely hammered his farm. His wheat, it just matured way too fast, shriveled up. He ended up with maybe half of what he expected.
And that single failure, Preetam Singh's experience, it echoed across the whole country. India's total wheat production dropped by 3 million metric tons because of that heat wave.
3 million tons.
Yeah. Suddenly, this climate event becomes a global supply crisis. India had to slam the brakes on wheat exports just to make sure its own people had enough food. That's the reality we're dealing with now.
Okay, but here's where it gets interesting, and this is really why we're doing this deep dive. Fast forward just 2 years to 2024. Spring temperatures were again, really high, one of the worst in a decade.
Right.
But Singh felt, optimistic, and his harvest, it actually beat his expectations.
So what changed?
The seeds. He was using these fundamentally hardier seeds, climate-resilient strains, and they were developed using techniques that are both cutting edge and, strangely enough, pretty old school.
And that success story really sets up our mission for today, doesn't it? We need to look back at the original Green Revolution, GR 1.0. It saved millions, no doubt, but it had significant problems, huge limitations.
Okay.
So now we'll explore what this GR 2.0 needs to do differently. We're focusing on how those same conventional breeding methods from the 20th century are now being, adapted, really weaponized, to fight these 21st century climate threats, the extreme heat, the unpredictable rain.
Let's start with the organization behind these seeds. CIMMYT, that's the International Maize and Wheat Improvement Center.
Norman Borlaug's legacy, basically. The Nobel winner who really drove the first Green Revolution. CIMMYT is still the powerhouse for global crop resilience.
So how are they actually doing it? What's the method?
Well, what's fascinating is that the core technique is conventional breeding. They've been refining this since, 1943?
Wow, that long.
Yeah. It's meticulous work. It's not about, super flashy gene splicing for these particular wheat strains. It's about selecting parent crops that already have traits you want. Maybe they handle heat well or resist a local pest.
Okay.
Then they crossbreed them, grow out the offspring, and then comes the really intense part. Selecting the absolute best one out of maybe hundreds of thousands of individual plants. And they do this over and over, cycle after cycle.
So just to make it super clear for everyone listening, this painstaking crossbreeding, selecting the best, it's different from what we usually think of as GMOs, right? Where DNA is directly edited or injected.
That's a really crucial distinction to make, yeah. What we're talking about here for these wheat varieties is conventional breeding. It leverages the natural genetic variation within the crop through selection and intercrossing. It's not the same as direct genetic modification like CRISPR or gene injection.
Yeah.
Now, MYT does use some of those genome editing tools in other research, especially on maize resilience, but these widespread climate-resilient wheat varieties, they're products of this really rigorous conventional approach.
Selecting the best from hundreds of thousands. That sounds like an almost impossibly huge task. How does an organization like CIMMYT even manage that kind of scale year after year?
This scale is just immense. MYT runs one of the world's biggest gene banks for maize and wheat. Think of it like a global library holding all this potential genetic diversity.
A library of seeds.
Essentially, yeah. And their impact reflects that scale. They're credited with developing something like 2/3 of all the wheat varieties grown globally today, and about 1/3 of the maize.
2/3 of the world's wheat varieties. That is a massive footprint.
It really is. And you see the urgency in how quickly these new strains are deployed. Those climate-resilient types that helped Preetam Singh bounce back. They're already being planted across 40 million hectares just in India. That's a huge, rapid rollout, applying this established science to a very new and pressing problem.
Okay. If IMYT is building on this older method, we really need to understand that foundation.
Yeah.
Let's talk about GR 1.0, the first Green Revolution. What time frame are we looking at, and just how successful was it?
So the main period for GR 1.0 is generally seen as, say, 1966 to about 1985. It was this huge international push, mostly public money funding crop improvement and building infrastructure. The idea was adapting Western scientific breakthroughs for developing nations.
And the results were just game-changing, right? It basically stopped those Malthusian predictions of worldwide famine in their tracks.
Absolutely. Global production of major cereal crops tripled. And this happened even though the amount of land being farmed only increased by about 30%.
Wow.
The yield increases were just astronomical. If you look specifically at developing countries from 1960 to 2000, wheat yields jumped 208%, rice was up 109%, maize up 157%.
Incredible numbers. And that obviously had a huge economic ripple effect, didn't it, for ordinary people?
A profound effect. This flood of high-yielding varieties directly pushed down real food prices across the globe. People could afford more food.
Right.
Some estimates suggest that without GR 1.0, global food prices could have been like 35 to 65% higher, and calorie availability per person, maybe 11 to 13% lower. So it wasn't just about preventing starvation, it was about economic relief, too.
And this success led to a more permanent structure.
Exactly. Building on the early wins from CMYT and IRI, the International Rice Research Institute, they created the Consultative Group on International Agricultural Research, or CGIR.
CGIR, okay.
Its whole purpose was to generate these international public goods, basically making sure that technological advancements, the improved seeds, could spread easily across borders and benefit everyone, not just be locked up in one country.
It sounds incredibly successful on paper, but like you said, there were downsides, big ones. As we think about GR 2.0, we have to confront those unintended consequences. What went wrong?
Well, the biggest issue was probably how uneven the benefits were. GR 1.0 really focused on the easy wins areas that already had good irrigation or plenty of rainfall.
So the places that needed it most got left behind.
To a large extent, yes. The poorest regions, the ones relying on rain-fed farming or stuck with marginal land, they saw the slowest improvements.
And that created gaps.
Big gaps. Take those high-yield wheat varieties. In irrigated areas, farmers might see a 40% yield boost. Amazing. Yeah. But in the dry zones, maybe only 10%. If that. So it actually widened the economic divide between regions within countries.
And I understand some policy choices back then made things worse.
They often did. The push for maximum yield led to widespread monocropping, planting the same crop over huge areas. And it encouraged heavy use of chemical pesticides and fertilizers.
Which has long-term consequences for the soil.
Absolutely. Lasting impacts on soil health and water resources. Plus, the cost of the whole package, the special seeds, the chemicals, was often too high for small farmers. They just couldn't afford to get on board.
There was also a gender dimension to this, wasn't there?
A significant one. Most of the training, the technology transfer programs, they were aimed squarely at male farmers. So women farmers or households headed by women, they often benefited proportionally much less. That's a critical lesson for GR 2.0.
And this history directly informs the criticisms we hear today, right? People like Gurpreet Debrikana arguing CMYT is still too focused on the crop itself, not the soil it grows in.
That's the core of the modern critique, yeah. Is the focus still too crop-centric? If you push for resilient varieties without equally pushing for sustainable farming practices, do you risk making problems like topsoil degradation or poor water retention even worse?
A tough balance.
It is. And there's the nutrition angle, too. While GR 1.0 boosted overall calories, it sometimes led to less diverse diets.
How so?
Well, these high-value staple crops sometimes displaced more traditional local crops, things like pulses or certain leafy greens, which were actually really important sources of micronutrients, iron, vitamin A, zinc. So more calories, yes, but persistent or even worsening hidden hunger.
So GR 2.0 isn't just about yield or even just sustainability in the broad sense. It's about building resilience against a climate threat that seems to be accelerating.
It's accelerating fast. Think about those states in northwest India we mentioned, Punjab and Horeana.
Yeah.
They usually get maybe 5 or 6 days of extreme heat wave conditions per year. The forecasts now, they're predicting roughly double that number moving forward.
Double. And you said heat is particularly devastating for wheat. Why is that, scientifically?
It hits during a really critical growth stage called the grain filling phase. This is when the plant is basically pumping nutrients from its leaves into the kernel, the part we eat.
Okay.
If temperatures get above 30 degrees Celsius, that's 86 Fahrenheit, that whole process just slows right down. The kernels don't fill properly, they end up smaller, and your yield just tanks.
And there's a way to quantify this potential loss globally. How does that work?
It's a chilling calculation. One major study estimated that for every single degree Celsius rise in the average global temperature, the world's farms will produce about 120 fewer calories per person per day, simply because staple crop yields will be lower. That's the stark reality driving GR 2.0.
Okay, so the strategy has to be different this time around. Not just more yield. What's the approach now?
It's sort of a three-part focus. Yes, pushing the yield potential higher is still important, but equally critical is boosting tolerance to heat, drought, and to pests and diseases, the biotic stresses.
Right.
And the third piece, hugely important, is improving input efficiency. The new varieties have to thrive using less water, less fertilizer. We can't just keep pouring resources onto fields.
And getting this done requires different kinds of partnerships now compared to the 60s and 70s. It's not just public research institutes anymore.
Absolutely not. Collaboration with the private sector is essential now. You see examples like Sam YT working with Monsanto before the Bayer acquisition on drought-tolerant maize for Africa.
How did that work?
Monsanto provided some of its proprietary genetic material, its germplasm, and CMYT, with its public mission, adapted that into high-yielding varieties suitable for African farmers. It's that kind of blend you need for impact and scale today.
Plus, they have digital tools that the pioneers of GR 1.0 couldn't have imagined.
Oh, completely. Remote sensing, satellite imagery, spatial mapping. They can target interventions much more precisely now, see where help is needed most, track progress.
And things like mobile phones.
Huge. Farmers getting real-time advice, applying water or fertilizer more smartly based on actual conditions. That's precision agriculture, making every drop of water, every bit of input count.
But even with all this amazing science, we need to come back to the farmer, right? Preetam Singh, the guy whose harvest bounced back in 2024. He still had reservations.
He absolutely did, and his perspective is maybe the most crucial data point here. He said, yeah, these new varieties, they can handle maybe 2 or 3 degrees more heat than the old ones.
Which is good, but...
But he asks, what if the temperature grows higher? He was also really honest that luck played a part. Getting a few timely rain showers made a big difference, even with the better seeds. We haven't engineered climate dependency out of the equation entirely. Not yet.
So that really lands us on the main takeaway. This whole new push, it's maybe best thought of as a doubly green revolution.
That captures it perfectly, I think. GR 1.0 was laser-focused on maximizing yield, stopping famine. GR 2.0 has to do that and build intolerance, boost efficiency, and ensure genuine long-term sustainability for these incredibly stressed farming systems. It's a much taller order.
And why this matters directly to you listening right now. Well, India is the second biggest wheat producer on the planet. What happens to their harvest directly impacts global food supplies and the prices you pay.
It's estimated India's wheat meets something like 35% of the world's nutritional needs derived from wheat, so stability there matters everywhere.
Right.
Which brings us to maybe a final point to really chew on, the need for sustained investment. Take wheat rust, a fungal disease. For years, research kind of dried up because people thought, oh, we've solved rust resistance.
Complacency set in.
Exactly. And that created the opening for a new, highly virulent strain, UG99, to emerge and spread like wildfire, threatening harvests globally.
Wow.
So the success of GR 2.0 isn't just about these current breakthroughs. It depends entirely on sticking with it, consistent long-term funding to keep improving resistance, keep adapting as the climate changes and new pests or diseases inevitably emerge. It's a race without a finish line, really.
Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other podcasts, responding to the content, and checking out our related articles at helioxpodcast.substack.com.